Okay, guys, so I would like us to look at a reduction formula. So under reduction formula, basically, when we are using integration by parts, if we have integrals of this form, these types of integral would require us to use integration by parts twice. And if we have integrals of this form, then we would be using integration by parts 3 times. And if we are to have integrals of this form, then it would mean we are using integration by parts 5 times, 6 times, and 8 times. And obviously that would really take a long time for us to integrate. So we have the reduction formula, which basically provides a quicker method to use. So let's say we want to integrate, we want to carry out the integrals of the form xn exponential x dx. So using the integration by parts method, let this be u and let this be dv. So we want to come up with a general formula of integrating any value x raised to power n. Now integration by parts formula is uv minus integral of v du. Since we already have our u, which is equal to xn, we can be able to get our du dx. So our du dx will be the derivative of this, which is nxn minus 1. And since we have our dv, which is equal to exponential x dx, we can get our v, which is basically the integral of this, and that will give us exponential x. So inputting into the formula, this formula here, we have uv. Our u is xn multiplied by v, which is exponential x, minus integral of v, which is exponential x, multiplied by du. And our du, if you make du the subject of the formula there, we'll have nxn minus 1 dx. So rearranging this basically gives us, remember, we were looking for the integral of xn exponential x dx, and we found out that it is equal to xn exponential x minus, we can take this constant n outside the integral sign, so that we have xn minus 1 exponential x dx. So if we look at whatever values we have inside the integral, they are more or less the same. Look at this and look at this. The only difference is the power of x. Here we have x raised to power n, and here we have x raised to power n minus 1. So if we decide to call this, let this be equal to in, then let this be equal to in minus 1. So we can write the general formula of in, getting the integral in, that is the integral of x raised to power n exponential x dx, is given by x raised to power n exponential x minus minus n in minus 1 plus c, such that if, let's say, we are told to find the integral of, x raised to power 1 exponential x dx, using integration by parts, we could just do this very fast. We will have this as u and we will have this as dv. Then the formula uv minus integral of v du would give us u is x, v is exponential x, minus integral of exponential x multiplied by du, which will be dx. And this will be x exponential x minus, if you integrate exponential x, you get exponential x plus c. If we were to use the formula, so we want I1 using the general formula that we found here, which is this. We want to get I1 when x is raised to power 1. So what is our I1? Our I1 will be x raised to power 1 exponential x minus 1 I1 minus 1. And this will basically give us x exponential x minus I0. Then what is our I0? Let's come and evaluate I0, still using the general formula. So we are using the general formula here. We are still using it to get I0. So that will be x raised to power 0 exponential x minus our n now is 0 into I 0 minus 1. So this basically will give us x raised to power 0 is 1. So we will have exponential x and this will be 0. So our final answer here will be x exponential x minus I 0, and our I 0 is exponential x plus c. Clearly, the same value we get when we are evaluating using integration by parts. So after we have this formula, we generally don't have to use integration by parts. We can just use this formula to evaluate. Let's say we want to get the integral of, let's say we want to get integral of x cubed exponential x dx. So this is basically our I3. Now look at the general formula. Our I3 will be given by x raised to power 3 exponential x minus 3 I3 minus 1, which is basically I2. So we go ahead and evaluate for I2, still using the general formula. So what's our I2? Look at the general formula. I2 will be x squared exponential x minus 2 into I2 minus 1, which will be I1. So we still need the value for I1 so that we are able to replace, still using the general formula. So still here, I will get my I1. What is I1? Look at the general formula. It will be x raised to power 1 exponential x minus 1 I raised to power 1 minus 1, which is I0. We still need to get our I0 so that we are able to replace here. So what's our I0 using the general formula? It will be x raised to power 0 exponential x minus 0 into I0 minus 1. Okay, fine. So now replacing all our values into I3. So clearly we can see I3 is equal to, so I'm going to do the replacement. I3 is equal to x cubed exponential x minus 3 of I2. But what is I2? I2 is x squared exponential x minus 2 of I1. But what is I1? Look at this. X exponential x minus I0. But what is my I0? Look at this. I0 is x raised to power 0, which is 1 exponential x. So I0 is just basically exponential x. So evaluating all that to get I3, we'll get that our I3 is equal to x cubed exponential x minus, if we open the bracket here. So first of all, we could just have it as this, and then we first of all open this bracket. So this will be minus 2x exponential x, minus will give me plus 2 exponential x. Then finally, I3 is equal to, so this is x cubed exponential x, open this bracket, this is minus 3x squared exponential x, open this, minus will give plus 6x exponential x minus 6 exponential x plus c, which basically gives us our answer for I3. So basically that's how we go about evaluating such. Let's take up another example. Let's say we are looking for I4. So how do we go about getting I4? So let's take up, so you're told to get the integral of x raised to power 4 dx. Now, we already know that the general solution, IN, so IN is equal to xn exponential x minus n IN minus 1. That's what we got when we evaluated here the general solution, xn exponential x minus n IN minus 1. So having that in mind, then what is our I4? So where there's n, you replace with 4, x4 exponential x minus 4I3. This is our answer. But now we need to get I3. Let's go on and get I3. So I3, we are now just using the general formula to get this value. So I3 will be x cubed exponential x minus 3I2. Then now we need to get I2. So still using the general formula, what will our I2 be? So I2 is equal to, so still using the general formula, that will be x squared exponential x minus 2 I 2 minus 1, that will be 1. We now need to get the value of our I1. So what is our I1? X raised to power 1 exponential x minus 1 I1 minus 1, which is I0. And finally, what is our I0? So our I0, still using the general formula, is x raised to power 0 exponential x minus 0 I0 minus 1. So if we replace all this value into our answer, which we'd already gotten, so this was our answer. We found that I4 is equal to x raised to power 4 exponential x minus 4I3. But what is our I3? Our I3 is x cubed exponential x minus 3I2. But what is our I2? Our I2 is x squared exponential x minus 2 of I1. But what is our I1? Our I1 is x exponential x minus I0. And what is our I0? X raised to power 0 is 1. So our I0 is exponential x. So we have exponential x there, obviously plus c. So simplifying this, we have our I4 being equal to, so x raised to power 4 exponential x minus 4 into x cubed exponential x minus 3. So minus 3 into x squared exponential x minus, so let's open this bracket up. So this is minus 2 minus 2x exponential x minus will give me plus 2 exponential x. Then we have plus c. Okay, opening this up, we have exponential x minus 4 into x cubed exponential x. So use minus 3 to open the whole of this bracket. We'll have minus 3x squared exponential x minus will give us plus 6x exponential x minus 6 exponential x plus c. And finally, using 4 to open that whole bracket, so we'll have x raised to power 4 exponential x. Then this will give us minus 4x cubed exponential x minus will have plus 12x squared exponential x minus 24x exponential x minus will give us plus 24 exponential x plus c. And this is our answer. So that's how we go about that particular reduction formula. That's how we go about that particular reduction formula, guys.